चिल्ड्रन। सो आज हम फाइंड आउट करेंगे सेंटर ऑफ मास ऑफ सेमी सर्कुलर रिंग। सेंटर ऑफ मास of semi circular ring. Now to find the center of mass of this kind of half part of the ring, right? Center is over here. If it would have been complete circle, this is the center. I have to find the center of mass of this semicircular part of the ring. So as per the definition, as we know, considering with respect to the center, so I will just make two axes, this and this one. Right? With respect to this point, we have to find the center of mass of this semicircular ring. So if we divide this ring, very small elementary part, number of parts will be there, right? So many parts it can be made. बहुत से parts ऐसे बनाए जा सकते हैं. So suppose this length is ds, small length. Radius of this semicircular ring is r. Let this theta angle be theta, and the small angle it is d theta. Therefore, ds will be equal to what? That is r d theta. Length of the small elementary part of the ring, right? ds is r theta, and let the mass of semi-circular ring is equal to capital M. So mass of the semicircular ring is m and radius is r. Therefore, mass per unit length is equal to m upon pi r, because total circumference is 2 pi r and this much length is pi r. So mass per unit length is m upon pi r, and this is, suppose we are considering this as lambda, right? So mass of this length, mass of ds, therefore mass of ds is equal to dm is equal to lambda ds, right? And ds is r d theta, therefore lambda r d theta. So this is the mass. And if you look at center of mass for this very elementary part, ds is x-axis. This is x-axis. This is y-axis. So this is the x-coordinate of the center of mass of ds, and this is y-coordinate of this. This will be how much? That will be r cos theta. This will be r sin theta, right? So we can find, I will take the y coordinate first. X coordinate, if you look at, due to symmetry, because this ring is symmetrical about y axis, so x coordinate of center of mass will be 0, since you are considering this point. From here we are measuring, right? So we can find y center of mass, y coordinate, integration of x, that is y dm upon capital M, mass of this total. So this M I have written over here. So see, what is Y? Y is R sin theta. This is R sin theta. Y is R sin theta. The integration, that is R sin theta into dm. Dm is equal to lambda R d theta upon M. Now theta is varying from where? From here to it is total length if you are considering theta, because small ds will be taken, all small ds, means theta will be varying from 0 to pi. So we can write it is 0 to pi. And if you simplify this, we will get the y coordinate of center of mass of this semicircular ring. So see, we will write YCM is equal to 1 by m. We will take common, and this will be lambda r, is r square. As a matter of fact, r sin theta into lambda r will be taken common. Integration of 0 to pi sin theta d theta, that is equal to lambda r square upon m. Sin theta, if you are integrating this, that will be minus cos theta 0 to pi. That is going to take minus again outside, minus lambda r square by m, that is cos pi minus cos 0. And what is this? Minus lambda r square by m. This will be minus 1, minus 1. Your cos pi is minus 1, cos 0 is 1. So minus and minus total, it will be plus lambda r square upon m into 2. Put the value of lambda. Therefore, YCM, y coordinate of center of mass, y coordinate of center of mass will be this. So r square upon m into lambda is m upon pi r, m upon pi r into, that is 2. Just to simplify, m and m will go, r and r will go, that is 2r upon pi, that is y center of mass. If we find x center of mass, we will find that x center of mass will be 0. How? Instead of writing r sin theta, we will write r cos theta. In fact, it will be 0, but mathematically we will look at. So that is XCM. Same thing we will write 0 to pi. Instead of writing r sin theta, we will write r cos theta, right? Into lambda r d theta by m. If we simplify this, you will get lambda r square by m and 0 to pi cos theta d theta. And this is lambda r square by m, right? And cos theta, if you integrate, we will get sin theta 0 to pi, that will be equal to 0. Because sin pi minus sin 0, sin pi is 0, sin 0 is 0. So coordinate of center of mass of this will be, therefore coordinates of center of mass is equal to, x coordinate is 0 and y coordinate is 2r by pi. So 2r by pi, it will be on y axis, it will be somewhere here. So this distance is 2r by pi. This is center of mass. This way we could find what is the center of mass of the semicircular ring. So likewise for hollow sphere, if you have this hollow sphere, then what is the center of mass, that we will find in the next video. Till then, all the best.